Hi friends, having studied the history of pesticides, classification of pesticides, mode of action of a different group of pesticides in insects and their insecticide resistance and its management. Even then, insecticides are one of the major components in insect pest management that everybody can understand. To use insecticides in IPM, we should have three items to be considered. One is the physiological selectivity, another one is ecologically we should select the insecticide for inclusion in the IPM, third one is behavioral selectivity. So, these three are most important in including in the IPM module, and all these three things should standardize its time of application, its dosage needs to be applied and the formulation to be used. So, time, dose and formulation are most important in all the three cases. Coming to the first one, physiological selectivity of insecticides. Insects growth and development includes some of the hormones. Particularly the juvenile hormone is very much required in maintaining the juvenility of the insect, particularly in the larval development. If any compound interferes in its synthesis, then the insect growth is affected. We have commercially synthesized juvenoids which interferes the synthesis of a juvenile hormone, thereby the molting to the next stage is affected. So, commercially lot of juvenioids are available as insecticide for use. Similarly, the another hormone required for insect growth and development is molting hormone or ecdysone, which is very much required for the molting process. If any hormone, if any substance that interferes with the synthesis of molting hormone, again disrupts the larval development. Commercially, many syntheses have been undertaken wherein the chitin synthesis inhibitors are commercially available in the market. So, when used as insecticide, the molting is affected, resulting in death of the insect. Lastly, many of the microbial organisms, in particular bacteria, viruses, they are very specific to insect cell, and viruses as you all know is very specific to the nucleus itself. So, they can be used as microbial insecticides under specific IPM situations. Coming to ecological selectivity, one needs to study the life cycle of a particular insect pest before its management. By studying the life cycle of the insect, we will be understanding the weak points in its developmental stages or in its life cycle. By knowing the weak points, we can use very minimum insecticide which is most effective at a low concentration. Thereby, the target species can also be checked as well as the natural enemies can also be prevented. To quote an example, in case of cotton, in the first early days, that is up to 30-35 days, leafhopper or jacid is one of the important pest on cotton. It affects the growth of the plant. This can be effectively checked with a seed treatment chemical or insecticide at a low dosage, just about 5 grams per kg of seed, which not only checks the leafhopper or the jacid incidence, but spares the natural enemies in the ecosystem. Thereby, we also get the benefit of these natural enemies in preventing the leafhopper population. The another important insecticidal selectivity is behavioral selectivity. Based on studying the insect behavior, because each species has its own behavior, from insect to insect there is variation. Again, within the insect, a larvae has a different behavior, adult has a different behavior. Once after studying the knowledge of this behavioral impact, it can be very well used to our advantage. To quote an example, in case of Spodoptera, which is a leaf eating caterpillar, which is a polyphagous pest on many crops, wherein the larvae is the damaging stage, which is nocturnal in habit. That means it feeds during night time only. So, this larval behavior, that is feeding during the night time, we have to use it in the IPM practice. Any application of insecticide during daytime will not work efficiently, because the larvae will not be active at all. The same thing, the same pest can be effectively checked if used poison bait technique, using insecticide and molasses and some ingredient. Prepare the poison bait and sprinkle in the field wherever the Spodoptera problem is there during dusk hours, which effectively controls even the grown up larvae also. So, that is why this behavior can be used in timing our IPM practice. Coming to the integration of insecticides in various methods of control, even these insecticides can be very effectively integrated with biological control itself, leave aside other methods. To quote an example of integration of insecticide with biological control, say in case of cotton, the first 30 days seed treatment can work, wherein there will not be any foliar application of insecticides, and then the bollworm damage starts, particularly the adult moths start laying their eggs on the young squares, then the flowers, and these egg population can be prevented by inundative release of egg parasitoid Trichogramma species. Maybe 1 or 2 applications will bring down the population in the egg stage itself. Later on, sprayable formulation of insecticides can be used. So, this is how seed treatment followed by inundative release of egg parasitoids, then followed by spray formulation of insecticides can be integrated. Then all these insecticides, they only act as a curative control. Whenever the damage is there, whenever we apply insecticide, they effectively bring down the population. Then all these insecticides, will have a rapid curative measure. So, immediately after seeing the economic damage, if you apply, the incidence will come down below the economic threshold level. And another feature of insecticides is they have a wide range of uses, and their application technology also varies from species to species and crop to crop. One need to know before integrating insecticides in the IPM schedule. Lastly, and the most important, the benefit cost ratio of insecticide use is most important. In majority of the cases, or rather in all the cases, 1 to more than 1 ratio should be there with insecticide use. There are examples that by spending 1 rupees, there is a benefit up to 10 rupees. That means 1 to 10 is also there. So, anything I said 1 to more than 1 is always favorable in insecticidal management. Benefits of pesticides also we should understand. So, as I said, these pesticides are most effective and reliable against wide variety of insect pests in a given crop, in a given ecosystem, and they are very effective or quick acting on the stage of the insect that we want to manage, and as I said, they provide immediate cure. Then they are most economical when used appropriately. That means at the right time, at the right dosage, if used, they are most economical. And for the farmer point of view, it is very easy to apply insecticides compared to some of the other methods of insect pest management. And then whenever there is a new insect on a crop, we can test a particular insecticide within 1 season and then immediately recommend or include in the IPM package, but the same thing will not hold good with reference to resistant varieties or with reference to natural enemies integration, because each technology takes about 4 to 5 seasons before including in the IPM package. Some of the negative aspects also we should know. So, as I already dealt, all pesticides, if used indiscriminately or regularly or continuously, chances of exposure is much more, and the development of resistance to insecticide happens for various insects. We have classic examples already I have indicated. And another thing is insecticidal application to the applicator itself, starting from headache, vomiting to carcinogenity. There are lot of reports available to us. And then another important thing, the effect on non-target organisms, particularly the natural enemies, the pollinators, wildlife, and residues in the plants itself has got a major negative effect. Then the factor concerned with environmental contamination, the food residues left, the insecticide residues left in the food and water cause a major threat to higher animals and human being. Lastly, the insecticide synthesis itself, in the production stage itself, one need to take care. In its transportation, one need to take care. Even in its storage at the retail level also, one needs to take, otherwise a lot of environmental hazards, risk hazards are associated. Knowing all these things, even today, particularly in tropical and subtropical conditions, because of the insect population outbreak, we need to include insecticides in the IPM, and we need to observe a definite framework. In my opinion, it should be used only to avoid the predictable economic damage. Whenever the other control measures are not working, then only we need to go for insecticide application in the IPM strategy. Secondly, these insecticides work as an alternative means, and they are curative. As I said, they are curative in its approach. Lastly, their socio-economic conditions also to be taken into consideration, particularly the cost of the insecticides and the benefit that we get also should be considered before inclusion in the IPM. So, to conclude, the insecticide from the practical perspective in IPM, each letter of the word insecticide carries a meaning. I should refers to an integral or integrated component. N refers to a rather insecticide should not become a necessary evil. S refers to it should not be a sole component, it should be a special component in IPM. E refers to economical, naturally the cost benefit ratio should be more. C is, as I said, always it is curative. Whenever you see the economic damage, immediately you can bring down using insecticides. It is time tested. T refers to time tested, that means with single testing you can immediately include in the IPM package. I is easily implementable from the farmer point of view. C refers to critical, that means at times of outbreak of insect on a particular crop, there is no other technique to overcome this problem. So, insecticide come to our rescues or to the farmer's rescue. And then I is, which is most important again from the farmer's point of view, income fetching, that it should be higher CB ratio. And then D, of course, it should be deadly to the target species, safe to the natural enemies, and lastly it should be very effective. So, considering each word with its own meaning, insecticides become a major component in the IPM. Thank you.